All right, lots of annotations again, but the basic logic is the same as before. Stata has still stored my regression results. So the regression that I ran in my earlier command here, that is still in Stata's memory. Everything that I need to add now, again, is my locals. I summarize age, but this time I'm not going to use the mean value and the standard deviations above and below the mean value, but instead I'm adding percentile values. If I use the detail option after summarize, I get the percentile values of age. For example, the first percentile is 34 years of age, the fifth percentile is 35, and so on, and the 99th percentile is 45 years of age. Those values that I see in my output window now, they are then saved as locals. I use the names P5, P25, P50, etc. to name those values, and they are now in Stata's memory. In addition, I'm also specifying the range of age for which I'm trying to plot this. And now I'm going to jump a little bit in my script to the bottom, where I again run my margins command. After having stored these values that you see in the output window, I'm using the margins command and look at the marginal effect, the first derivative of my regression function, at the values, at the percentile values that I saved earlier. The only thing that is really different from my earlier margins command is that I'm adding this dx, dy dx hours. So I'm looking at the margins as a function of the hours work. And that's how we get to the actual test of the moderation. So when we take the first derivative with respect to the hours worked, that is where I actually start testing the statistical significance of my marginal effects. The rest of the visualization is the same as before. I again use the margins plot. The only thing that I really changed compared to my earlier visualization is that I added this dy dx option and that I used a different range for my age so that I not only have 3 values for age, below the mean, mean, and above the mean, but I have a fuller range of age, and that helps me understand where exactly that becomes significant. Enough explanation, let's look at what that looks like. Remember, I have stored my regression results still in Stata's memory. I don't need to rerun it again. The only thing that I need to rerun, essentially, because I stopped here, is to put the locals into Stata's memory, and then I can directly jump to the marginal effects. In this case, I added the option quietly, which suppresses the output. We don't really need it. And then we can look at the margins plot. This is what it looks like. In terms of interpretation, it tells me where, in terms of the percentiles of age, the moderator, in this case age, is different from 0. We have the 0 line here. This is the gray dotted or dashed line. And everything that is far away from the 0 line means that it is significantly different from 0. In this case, the effect is statistically significant. What we see, okay, for low age, 5th percentile, 25th percentile, 50th percentile, 75th percentile, the curve is far above the 0 line, and also the confidence intervals don't overlap with the 0 line, which gives me a strong indication that here the effect is actually significant. The only thing where things become a little murky is at very high levels of age. So the 95th percentile, I think that was like 45 years of age. That's where the differences no longer is statistically significant, at least seemingly here. If we want to be 100% sure about this, we can also compute this difference. And that's where the code becomes a little tricky, I must admit. I'm not only going to give you the high-level logic and leave it for you to look at this after the seminar. So essentially what I want to do is I want to compute the marginal effect of hours at every integer of age value and compare each adjacent compare. So in other words, I want to look at the question where I ask, is the slope at age 30 different from the slope at age 31? No, and in this case, we look at percentile values. Is that really different? That's what I'm doing with the pwcompare, the pairwise compare option in Stata. We have the same margins command as before, but now we are also comparing whether any pairs are statistically different from each other. Next, I'm going to save these results in a matrix, and those results are then converted into vertical lines that indicate where the cutoff point is for statistical significance. There's a lot of code for essentially one line, as you will see, that shows where the cutoff point is. But what I want to see is at which point in this figure that you see right now on the screen is the cutoff point where the results are statistically significant. I think it's easiest if we just run the whole command and look at the results. I'm running this again, and you see the only difference is a gray vertical line at the 75th percentile. This line indicates that at this point, the result is still statistically significant, so the difference is still statistically significant, but after this percentile value, the results turn insignificant. That's what I'm adding here for my moderation. And that's a nice twist that you can add. It's completely optional. You don't have to do it. Also, in this case, just looking at the confidence intervals gives you a good sense of where the results are significant. But if you want to add it and be like 100% sure, you can do this extra computation and add that to your output results. And again, I save the results and I'm essentially done. What we've now covered is how can I test a moderation analysis in Stata for a linear regression where I have a linear predictor and a linear outcome model. And we have now seen two different ways in which we can visualize these results and also test where this result is statistically significant.